That other point. Our material is in this stamping process once it appears. So we've talked about some of these injuries. Metal damage. Sometimes we are outside. You can't tell from the outside because it is a mechanical process. Our metal materials. It's often expressed in this way. For example, our tape. When I'm about to bend it. I used such a punching method. In the process. At this location. Molecular chains of metals in its materials. Or between atoms. So that's actually van der Waals force. Then this invisible state of force. There are times. The forces between the molecules are actually broken. So from a microscopic perspective, there may actually be a fracture in it. But from a macro perspective, in the process, under microscopic conditions, it may have fractured. But in the macroscopic state, sometimes you can't see it. The vast majority, especially after electroplating the material, you can't see it, but it's actually broken inside. So once this product has such a terminal, in the case of power on, and it produces a very strange phenomenon. We call this the kind of battery effect. The battery effect. When it breaks, we know all about metals. It's actually a microscopic battery. Once powered on, it's a microscopic battery. Especially after the molecular chain inside is destroyed, it will produce this battery effect. This is plus a coating on the outer layer. After the two materials appear, and the outside of us is either gold or silver, right? It's got copper in it. That's obvious. It will produce one and form a positive and negative electrode. What is it called to form a similar one? Redox reaction. What about this time? The material will be corroded. It will corrode under working condition. What about this corrosion? We call this stress corrosion. When this cathodic corrosion corrodes to the surface, it will form a live mouth. What about this time? It may also be related to the oxygen in the air. It's a redox reaction. What about this time? There's another kind of corrosion. Electrochemical corrosion. This time, our products. There will be a larger demand. This is something you've probably seen before or experienced, but may pay less attention. A relatively common phenomenon. One of the most famous failed cases? That's a pretty big company. I was giving it to a very large international company before. This communication company, while doing, made this. What about this product? Everyone knows the RJ45 in the field of industrial application. What about our RJ products? You all know that. Its terminal is bent like this. Is that how our foreman got in? The terminal of our female head is such a structure. What about this structure? It needs to be reversed. What about this backlash? In this place. And of course, it has this bend angle. That's in this place. We only have this material 0.2025. Such a thin thickness. In such a situation, the material is in this position. In most cases, it forms microscopic cracks. Because of the special process of your stamping, it will crack in this place. When you put a layer of electroplating on the outside, in fact, you can't. To this crack. But actually in your case, something humid or some more serious oxidation. This salty air, in some places like this, in the case of such environments by the sea, the corrosion of this place, it's very fast, especially when powered on. It forms the microscopic effects of the battery we just talked about. Now, this failure, it turns out, is very fatal. It will form quickly. First, patina. Second, there will be a drastic decrease in materials in this place. At this time, the contact resistance will become larger, especially in the field of communication. As soon as the contact resistance in this place increases, the whole system may generate a signal. Completely this disorder. So in our stamping process, that mechanical stress and our exterior. So that's a remarkable characteristic of the rupture. And it's a very important thing to be concerned about.